differential equation.
This is a common question that shows up on the AP Calculus. Step 1 is to separate your variables on each side of the equation. Step 2, integrate both sides of the equation. Step 3, solve for C. And then step 4, plug in your constant to solve for Y.
We're going to start with a simple example. Alright, so the first step was to separate the variables. So we would do this and get. As you can see, we just cross multiplied to get these equations. Step 2, we integrate both sides.
I'm just typing up all the questions, Meg. Okay, where's C? It's on the other side.
As you can see, when you take an integral, there's usually a C on both sides, but since C is any constant, we can only use it for one side if we want to, and in this case we need to, so we can solve for it. So now we just solve for C.
We're typing the question. Are you typing the whole thing? The whole problem?
I don't know.
Yeah, but the question, one of the parts of the
Each
question
question.
has.
Oh, okay. Yeah, okay.
I wish it was like. Just write that one. Okay. Just write C on the list.
Look what I did.
All we did here is we divided the 1/2 over, got rid of the 1/2 in front of here because of that. C, since it's any number, wouldn't change, it would still be C. And then we did a square root over here and square root both sides to get us y equals plus or minus x plus square root c.
The next example is dy dx equals y squared multiplied by 6 minus 2x through the point
Actually, I'm pretty sure
3
you don't, because I can't
and 1. Step 1 is separate your variables. So you're going to divide your y squared to this side, dy over y squared, and then multiply your dx to the other side, giving you 6 minus 2x multiplied by dx. Step 2 is you integrate both sides. Once you integrate both sides, you'll get a negative 1 over y equals 6x minus x squared plus c. And then the next step is you plug in your x and y into the equation. So your negative 1 over 4 equals 6 times 3 minus 3 squared plus c. So negative 4 equals 9 plus c. So c equals a negative 13. Next step is you plug in the c you got in the last step into your equation to solve for y. So it would be negative 1 over y equals 6x minus x squared plus, just kidding, minus 13. So then you bring over your negative 1. So 1 over y equals a negative 6x plus x squared plus 13. So y equals 1 over negative 6 plus negative 6x plus x squared plus 13. And that is your answer.
This could be a common separable differential equation problem you could see on an AP. First part, they're asking about slope field. So with slope field, they give you the equation. All you do is you plug in the x value and the y value for each point, and then whatever slope it gives you, that's the slope, and you just draw it in. So let's take 0, 0. You plug in 0 here, so it's 0 squared equals 0 minus 1. Obviously, this equals 0, so that's 0, 0, just a straight line. 1, 0. Plug it in. X equals 1 squared, 0 minus 1. 1 times negative 1. Negative 1 slope. Negative 1 slope. And so on for each point. Alright, so this could be the second part of the same question. While the slope field in part A is drawn at only 12 points, it is defined at every point. Describe all the points in the xy plane for which the slopes are positive. So if we come here and take a look at the slopes, this is what we got as our slope plane. We can see that these here are the positive slopes. This is due in fact to the equation. When x is squared, it is always positive except for 0. So this is 0, this is 0, and this is 0, only because x equals 0. So x cannot equal 0. Second, we go to the next part of the equation, y minus 1. Because of this, any value that y is less than 1 is automatically not positive. So y must be greater than 1. It cannot be equal to 1 because y is equal to 1, like here, it's just 0 and it's not a positive slope. So, we write our answer out. We gotta make sure I wrote it out. All points in which x is not equal to 0 and y is greater than 1 have positive slopes. This is because x is squared, causing it to be positive except at x equals 0, and that y will be positive if y is greater than 1, since y is since the part of the equation is y minus 1. Alright, so now that we separate them out, we integrate both sides. So by doing this, we end up with as you can see, when we integrate this part, we have to use the natural log with absolute value brackets. And this one was normal, but make sure you have the C. Never ever get the C. So now we go back to this. This is where we get our points.
Okay.
Alright, so this tells us that y equals 3, x equals 0. So we plug them in. When we plug in 3 here, we get natural log of 2 equals 1/3 0 plus c. This here is going to end up just canceling out because of the 0, and we're going to get natural log absolute value of 2 equals c. Alright, now that we found c, we're going to plug it back into the equation we get after we integrate. So as you see here, ln absolute natural log of y minus 1 equals 1/3 x cubed plus natural log of absolute value of 2, since that is the c. Now, to get rid of the natural logs, we have to raise it over Euler's number. So, E that's our next step. Alright, so since we have used Euler's numbers, the ln natural logs drop out and we get y minus 1 absolute value equals 2 times e to the 1/3 x cubed. Now we simply add the 1. And lastly, we get rid of the absolute value brackets by doing equals plus or minus. And that is our final answer.